Okay. Now will come a problem. Get 1995 is a leaf is in the work pool, and at a given instant it is under the spiral vortex flow. How we can say it is a spiral vortex flow? Because the plane circular vortex flow, when we study, we can see that for the case of the plane circular vortex flow, this radial velocity component is some constant by r, as well as the v theta is some constant by r for the spiral vortex flow. Spiral free vortex. This is the problem of spiral free vortex. In that kind of the problem, it is looks like the streamline will be looks like in this way. Streamline is in this way. So hence the problem is telling that at any instant of time that you take it here, at any instant of time, it was some leap, we are having it. It was at the distance of 120 meter from the center. After the half rotation it has made, and when it come at here, 180 pi rotation it has made. From here to here, pi rotation is made. So now at what distance it is here? R. Previously it was 180, 120 meter. Now what is the distance here in this world? That is our question. So to solve this kind of the problem, we have to go for the streamline equation in polar coordinate. Streamline equation in polar coordinate. So what would be the streamline equation? dr by dr and r d theta by theta. So dr by d theta will gives you r vr by d theta. Vr by v theta in this equation you could be able to see here r by pi. So dr by r is equal to minus 1 by 5 d theta. So the limit, initially it was 120 meter from the center. Final we have to find out. Initially the rotation let it be 0. After half rotation means pi. So it is coming as the ln r by 120. This is coming pi by pi. So r by 120 exponential of minus pi by pi. So r value will comes is a 120 exponential of minus pi by 5, which answer will comes nearly 64 meters. To solve this problem, it will come nearly 64. But the idea of the problem is we have to go for the streamline equation because the leaf is just like a fluid particle. It is moving with the flow. As it is moving with the flow, so we have to find out the location. So it will be always in the streamline. So if you got the streamline equation, it would be easier to get this kind of the problem. So here the gate problem is completed. Now we'll see another types of the problems regarding the kinematics of the fluid. This is the problem we are telling about. The stream function is given here. Stream function psi is given to you, x squared minus y squared. You are asked to finding out what is the potential function. So first of all, you have to see that is there any existence of the potential form. So you know minus d psi by dy. This kind of the problem you have to approach in this. So u is equal to minus d psi by dy, which is coming in this operation. If you do it, it will come to y. It will come. And same way, v is equal to d psi by dx, which will come to x. Now existence of the phi. What is the existence? Because it should be e-rotational flow. Then only it will be exist. So e-rotational flow, two-dimensional cases it is. So two-dimensional cases dv dx minus du dy is equal to 0. So dv dx perform, if you perform dv dx, it is the 2. And du if you perform, it is also 2. 2 minus 2, it will definitely gives you the 0. So hence we can say phi is existing. Phi exists. So now we have to go for the what is the value of the phi? What is the value of the phi? So we rewrite this thing again in this problem. So u is equal to minus d psi by dy is equal to d phi by dx. Cauchy-Riemann equation. That is nothing but 2. Okay? Cauchy-Riemann equation. So this the equation is done. So d phi by dx is equal to 2y. Phi is equal to 2xy plus function of first, second equation, the v. So v is equal to d psi by dx is equal to d phi by dy. If you perform this d phi by this, if you perform this thing, what it will come? So the phi will come 2xy plus fx. So ultimately the phi value will come 2xy plus some constant. That will be the answer. 2xy, because here the constant, because this fx is nothing but the same 2xy. And this fy is the same 2xy. So the answer will come 2xy plus c. This is the answer. Constant. This way we have to, if you are given a stream function, you will getting the potential function. The same way, if you are giving the potential function, you have to finding out the stream function the same way. So in that case, the potential function is given to you. The phi value is given to you. Just opposite problem. Some constant. Okay. Now, u is equal to d phi by dx, x. V is equal to d phi by dy. So that is the minus 2y. uv, you are getting it. Then you have to taking that thing, whether it is an incompressible flow. If it is not an incompressible flow, so it will not satisfy. So incompressible, for checking, du dx plus dv dy should be 0. Du dx is here 2, dv dy is minus 2, so it is 0. So it is satisfying the incompressible equation. So there is the existence of the stream function as it is a two-dimensional case. So here, Cauchy-Riemann equation, you have to take it, this Cauchy-Riemann equation, u is equal to, same way, minus t psi by dy. So psi is equal to minus 2xy plus f of x. Same way here, d psi by dx. Psi is equal to minus 2xy plus f of y. So ultimately, the psi will comes minus 2xy plus some constant. So minus 2xy plus some constant will be the answer. Just we are utilizing the conceptual. If any function is given, you get the velocity. After getting the velocity, you are asked to find out the other function. So other function, whether it is exist or not. So potential function, what is the condition for existence? Irrotation. Stream function, a condition for existence is the incompressible flow, 2D incompressible flow. So we are first checking. After checking, we put the Cauchy-Riemann equation. After putting the Cauchy-Riemann equation, we do the integration, partial integration, and getting the values. Same. Next. The material acceleration is always 0. So material acceleration, what does it mean by material acceleration? So material acceleration is the dv, the material acceleration. Total acceleration or substantial acceleration, the same name under the scope of dv dt is a temporal component. Then there is the spatial part. Is the temporal part or local acceleration we are telling temporal component, or local acceleration we are telling this is the convective part, or advective, convective, they are telling so many. So this part is depends on the time. This part is depends on the space. So when the velocity is not a function of time, that means it's a steady. And when a velocity is not a function of space x, y, z, then it is a uniform. Uniform flow. So then the material acceleration will be zero. So the velocity is not a function of time, it becomes zero. Velocity is not a function of space, it becomes zero. So steady and uniform case. In case of the steady, temporal part will be vanished. In case of the uniform, the spatial part or advective part will be vanished. The answer is the material acceleration is always 0 for this case. Steady and uniform flow. Next thing is, in a flow field, the streamlines and equipotential lines are parallel, orthogonal everywhere in the flow field, cut by an angle, cut orthogonally except at stagnation point. The last day we have discussed this problem, if you remember. But again, recap of this part, because the streamline, if you consider, is a function of x and y. So d psi. If it is a constant along a constant streamline, a streamline, so it's a stream function is a constant. Along a streamline, the stream function is a constant. So d phi is equal to 0. What does it mean? Del psi del x dx plus del psi del y dy is equal to 0. Del psi del x is the b dx. Del psi del y is the minus u dy. So the slope of the streamline, the slope of streamline will becomes d by. In the same way, if you consider the phi is the function, say equipotential line or velocity potential line, equipotential line, another name is the equipotential line. So along the equipotential line, the phi is a constant. So d phi is equal to 0. D phi is equal to 0 means, so del phi by del x dx plus del phi by del y dy is equal to 0. We are considering del phi del x is u dx, del phi del y is v dy is equal to 0. So dy by dx of equipotential line is equal to minus u by v. So if you multiply these two slopes, in that case, so again I rub this thing. So slope of streamline into the slope of equipotential line. If you multiply this thing, it will come. The streamline slope is v by u, and this is minus u by v. So this will be minus 1 except stagnation point. Except stagnation point means except u is equal to 0, v is equal to 0. If v and u is 0, so this is a indefinite. So it cuts orthogonally except the stagnation point. So if this is the streamline, equipotential line, cuts is orthogonally. It will cuts its orthogonally always. So the cutting point there would be 90 degree angle. As the slope, the both slope multiply is equal to minus 1. So that is the case we are considering. So you have to remember everywhere it is cuts orthogonally except the stagnation point. It's the most important words so many times asked in the GATE examination. Next one problem, the Lagrangian description is given to you. X is given to you, Lagrangian description here, x is equal to x0, it is bar, and y is equal to y0 e to the power minus k. The flow field, so flow field u along x-axis is nothing but dx by dt. So if you do the differentiation of it, it will comes x0 k e to the power kt. So k into x0 e to the power kt is nothing but the x, k into x. Similarly, v is equal to dy by dt. We can do this operation because the Lagrangian description is given here. So this velocity is the particle velocity. If this particle velocity is a it is a neutrally buoyant particle, then we can say the flow velocity and particle velocity is the same. If it is a nuclear, you have to tell it the neutrally buoyant particle. So density is the same. So in that case, you will get the velocity of the flow and velocity of the particle is the same. So here, u0 minus k is equal to minus kt. So minus ky. So you see, u is equal to kx, v is equal to minus ky. U is a function of x space and v is a function of y. So hence we can say it is a non-uniform flow. But u is not a function of t, v is not a function of t. So both are not a function of t, so it is a steady flow. It is steady but non-uniform flow. This flow is a steady but non-uniform flow. This is the solution of this problem. This is a simple problem is given. U and v is given. You are asked to find out the acceleration. So uv is already given. You will, a point is given. So at any point xy is given and time is given. You are asked finding out the acceleration for this component. So what is the ax? Simply you are writing the ax. Ax is the variation is there. If you get it, so du dt plus u du dx plus v du dy. So du dt is, so du dt, if you do the operation 1 by is minus 1 by this u x by 1 plus t. Du dx is second because 1 by 1 plus t, so it becomes square. V is equal to 1 plus 2t into du dy is 0. Du dy is 0. So you see this term becomes 0. This term will cut each other. It becomes 0. Ax is 0. Same way, if you go for the ay dv dt plus u dv dx plus v dv. Already 0 is here, so answer must be the C. What is the cross verification of this problem? You have to do always a cross verification. 2y 1 plus 2t whole square minus into 1 more 2 and u 1 plus t dv dx is equal to 0, so 0 it is. And v 2y plus 1 plus 2t into 2 by, so 4y, so these two are the same, so it will also become 0. So ax is 0, axy is 0, ay also 0. So that is the answer for this question. So it's just a calculation, nothing in this problem. Here the steam function is given to you. Steam function x cube minus y cube in the two-dimensional case. So what would be the u? U will be minus d5 by dy. So 3 y square. And v will be the d5 by dx. So 3x square. At point 1 minus 1. At point 1 minus 1 is a 3 into minus 1 square. 3 into 3. So the velocity, the velocity magnitude of the velocity is nothing but u square plus v square. So 3 square plus 3 square. So 9 plus 9. So root over of 18. So root 18 is nearly more than root 16. Root 16 is the 8. So the answer is the 8. 4.24. You can verify this with the calculator. This is an easy problem, just giving steam function. You are asked to finding out the u and v. Here the possibility of the flow field with steam function. Which one of the steam function having the possibility is a possible irrotational flow? The same thing, the phi is given to you, psi is given to you. We are asked to finding out whether it is possible to phi existence. So you have to verify with it. U is just, you are getting u is minus d5 by dx dy. So minus 2. And v is equal to d5 by dx. So minus 1. Now here dv dx minus du dy. dv dx minus du dy. dv dx is the minus 2. minus of du dy is the minus 2, so plus 2 plus 2. So there is a 5 existence possibilities. This is the answer. Second, you can verify. Third, you can verify in the similar manner. One by one, you can verify it. So after this verification, you can tell me. Next is the some statements are given and whether which one is correct, they're asking. The streak line indicates the instantaneous position of the particle of the fluid passing through a point. Streamline of the path traced by a fluid particle with constant velocity. Here, which statements are correct, you have to choose here. So, this is one IS question here. The streak line indicates the instantaneous position of the particle of a fluid passing through a point. It's a correct statement. Next is the streamline at the path traced by a fluid particle with constant velocity. It's not there. A fluid particle cannot cross streamline irrespective of the type of the flow. Yes, the third statement is also a correct statement. Number 3 statement is the correct statement. First. So 3 is in the B and D. Now, the first statement is a streak line indicate instantaneous point of the particles of fluid, which all are passing through a point previously. So that is also a correct statement. So 1 is also a correct statement. Some prior time it has passed a particular point. Next, the streamline converged at the fluid is accelerated and diverged when retarded. It is also correct. So B is the answer. Next question is the streamline, path line, stick line identical when the flow is steady flow. So there is no doubt about it. Single tick you can find out flow is steady. A steady flow of diverging state streamline is a what will be happening here? It will have the convective, which kind of acceleration it will have? The steady flow, diverging state streamline. So streamline is steady flow, but it is not an uniform. It is not an uniform flow because it's a divergent streamline. So the along with the x-axis, it is varying. Along with x-axis, it is varying. So this idea will give you. Next is the velocity potential function is given. Phi is given, the magnitude is asked. The same way the phi is given to you. X square minus y square is given to you. So u is del phi del x. V is del phi del y. Simply you are getting it 2x minus 2y. So 2x is 2, so minus 2. So 2 root 2 is the answer. The magnitude of the velocity vector is root u square plus v square, so 2 root 2. Simple. The existence of the velocity potential implies that fluid is irrotational. Yes, sir. Yes. Now, here also the velocity potential is given. You are asked to finding out. You just try this kind of the problem. The one function is given in the for the ideal fluid. So you have to which function in the phi exists. So you have to check the irrotationality of the flow. Similar type of the problem we are doing for a long time. So 1, 2, 3, 2, 3 more problem we'll do and we'll leave it this part. Here the angular deformation or vorticity flow field you are asked to finding out. So U has been given to you. U is 2xy and V is 2y square x square. So rate of angular deformation you were asked. So rate of angular deformation means du dy plus dv dx. That is the rate of angular deformation. And the vorticity vector field also you are asked. Del v del x minus du dy. Because only two-dimensional cases, so only k component is active here. dv dx minus du dy. So this is the cases 2x du dy. Here it is a dv dx is minus 2x. So it becomes 0. In that case, dv dx is minus 2x minus again du dy is 2x. So minus 4x. So this is the answer is the D in this case. Here also the stream function is given to you. You are asked to finding out the B. Stream function is given to you and the flow is rotational, they are telling. So again, U d phi by dy. So d phi by dy is minus d phi by dy is the ax square plus 3 dy square. And v is equal to d phi dx 2axy. Now, if the flow is irrotational, as it is a two-dimensional flow, so dv dx minus du dy is equal to 0. dv dx minus du dy is equal to 0. So dv dx means 2ay. And du dy is a minus 6b y. A is given as a 1. So y will be cancelled out. 2 minus 6b is equal to 0. So b is equal to 1 by 3. So same type of the problem is repeating in this manner. The same way the flow represents the incompressible or irrotation. You just check by this way. First you put continuity equation, then rotational equation, it will comes. This is another channel is given to you. Consider the steady compressible one diverging section. Steady flow diverging section. You are asked how much time it will take for the fluid particle to travel from x is equal to 0 to x is equal to n. The time. So hence the Lagrangian concept you have to invoke here. Hence the Lagrangian concept you have to invoke here. So v is given as the velocity vector is a one-dimensional flow. As it is a one-dimensional flow, so u is nothing but v0 1 plus x by 90 degree. U is equal to dx by dt. Lagrangian concept is taken. So dx 1 by x by L v0 into dt. If you do the differentiation 0 to time t time, here it is 0 to L going, but the time it will take ln 1 plus x by L 1 by L. It will be 0 to L v0 into t. So L of log 2. L of log 2 divided by V0 is equal to T. So L by V0, ln2 is the answer. The time required for this purpose. This question also is a UV is given. You are asked to finding out the lambda values for the incompressible flow. So you just here check the du dx plus dv dy is equal to 0. U is already given to you. So what is the U? U is the lambda x u minus x square y. So du dx will lambda y cube minus 2x. And v is given here, xy square minus plus dv, so 2xy minus 3y 0. So lambda is equal to 3 within a second.